Well, let's talk about ionic compounds. Ionic compounds are very prevalent. They occur in the Earth's crust as minerals. They're present in the foods that we eat. It's how our bodies get trace metals and other nutrients like that. Ionic compounds tend to be very stable because ionic bonds are very strong within that crystalline lattice. So examples of ionic compounds that we might eat, Morton light salt. Normal table salt is sodium chloride. The light version has potassium chloride in there as well. Sodium tends to raise your blood pressure, and if you have a balanced amount of sodium and potassium that you're taking in, it affects your blood pressure less than just eating sodium. It's one of the reasons I like Lay's potato chips, because they got a lot of sodium in them. They got a lot of potassium in them too. Yes?
Does it taste the same?
It does not taste exactly the same. Potassium chloride does not taste the same as sodium chloride. I think it's something you could get used to, though. Calcium carbonate is another ionic substance that you might eat. That's the active ingredient in Tums. That's going to help neutralize stomach acid. Here are a couple of examples of minerals. Calcite is also a form of calcium carbonate, but swallowing one of those calcite crystals is probably not going to help your acid reflux. And here's trona. This is got this complicated formula. This is an example where there are two different cations. We are not going to study the nomenclature of that, but it's interesting. Yes?
So if calcite and Tums are the same, then why are they different?
That's a good question. So in calcite, you have large, well-organized calcium carbonate crystals. In Tums, Tums have binding agents and other substances in there that will dissolve in your stomach so that you have lots of little tiny particles of calcium carbonate that can react with the acid. Yeah. Yeah, basically, you could make Tums out of this, I suppose, by crushing it into little tiny particles. Yeah. So we're going to learn how to write formulas for ionic compounds. So we start with the symbol for the metal cation with its charge, and the symbol for the nonmetal with its charge. This is going to be our work prior to actually writing the formula. You need to look at the formula for the ions with their charges, because the charges are what tell us how many of each to have. So we're going to put subscripts on each cation and anion so that we get an overall balance of charge. And then it's always a good idea to double check after you think you're done and make sure that it's correct. And we're going to do some examples. So ionic compounds, we always have a positive ion and a negative ion. You can't have an ionic compound with two positives or two negatives. The first element is usually a metal. The only exception we're going to run into is when the first ion is ammonium ion. Otherwise, it's always a metal. In the formula, the sums of the charges of all the ions have to add up to 0. So if you take all the positive ions, the total of their charge has to equal the total of the negative ions. They'll just be opposite in sign. And the formula is always going to give us the smallest whole number ratio. So you could write Na4Cl4, and that's giving us the correct ratio, but it's not the simplest. And so we're always going to go with the simplest formula for ionic compounds. So let's do some examples here. So we're supposed to write the formula for the ionic compound that forms between potassium and sulfur. So we need to write the formulas for these ions with their charges. So potassium, what's the element symbol for potassium? K. And the element symbol for sulfur is S. Now we need their charges. We learned how to do this in Chapter 2. What period of the periodic table is potassium in? I'm sorry, what group? It's in group 1. That tells us the charge. It's +1. So this is K plus. What's the charge on the sulfur ion? 2 minus. So you can take its group number, it's in group 6, and subtract 8, that'll give you -2. Or you can count backwards from the noble gases, right? So you would start in that row that has sulfur in it. Argon is 0, chlorine is -1, sulfur is -2. So that's the first step. Formulas for the ions with their charges. Now we have to figure out how many of each of these so that when we put them together, overall it's neutral. I would encourage you to understand what's going on, and then I'll show you a shortcut that you could do without understanding, and it'll work most of the time. So if I put these two together, I've got a +1 charge and a -2 charge. That doesn't add up to 0, right? So I need another potassium ion. Now if I'm adding up the positive and negative charges, now I've got +2 and -2. Each of these potassium ions has a +1 charge. Together it's +2. This sulfur has a -2 charge. +2, -2, those add up to 0. Tells me I need 2 potassiums and 1 sulfur. So the formula would be K2S. The metal always goes first. Why? Because we decided to do it that way. So my son's getting married in June, so there's all this wedding talk. So think about wedding invitations or any formal invitation. Is it addressed to Mr. and Mrs. or Mrs. and Mr.? It's always Mr. and Mrs. Why? Because they're oppressing women. No.
She's not married yet.
It's just a convention, right? It's just how people have done it, right? So the metal first. Metals are masculine in my fantasy world I call Mrs. K's Chemistry Land. Metal first, then the non-metal. So the guy, and then the girl. Mr. and Mrs. So the positive, the cation goes first, and the negative ion goes second. So it's K2S. If you wrote SK2, I would know what you meant, but it's like when my second child was 2 and we were in a restaurant. He's pointing over near the door and he's talking about the dollar biller. He meant the cash register. It was really cute. But if we walked around talking about a dollar biller, people would think we were weird, right? So I know what you mean, but it's not how we say it, right? So it's always the metal first. Any questions about that formula? Let's look at aluminum and nitrogen. Well, aluminum is Al. What's the charge on the aluminum ion? It's in group 3. It's 3+. Group 1 is 1+. Group 2 is 2+. Group 3 is 3+. How about nitrogen? -3. So start at the noble gas column and count backwards. -1, -2, -3. So here we've got a +3 and a -3. How many of each do we need, minimum, so that we can get a neutral substance? Just one of each, right? If I just shove these two guys together, I got +3 and -3. So this would just be AlN. Any questions? Metal first, then the non-metal. Mr. and Mrs. Yes? Where did I get the -3 from? That's a good question. So we find nitrogen on the periodic table, right? And the method most students seem to like is you start at neon. Neon would be 0 because the noble gases don't form ions. And then you count to the left. Fluorine's -1, oxygen's -2, nitrogen's -3. So for the nonmetals, count backwards from the noble gases. Yes? Yeah, group 4A, group 14, those guys don't really make ions. And so if you had to make it as an ion, I'd say I guess you'd say -4, but it could also be +4. You're never going to have to give the charge for those guys. Yeah. It's a good question. Yes? The crisscross?
Yes.
Yes, I was getting to that. So I told you I had a shortcut. Oh, you got a question?
Didn't you say that we should write N2?
Another good question. Isn't nitrogen a diatomic element? Doesn't it need a 2 after it? Okay, so as an element, nitrogen is diatomic. I think of those diatomic elements as being like junior high girls who never go anywhere by themselves. You know, one needs to go to the bathroom. They always take a friend. Somebody pointed this out to us at a school assembly when I was in junior high. And then I watched it, and we did that. It was like, wow, somebody's been spying on us. I did it myself, even though I was aware of it. I didn't want to go by myself. I took a friend. Those 7 don't want to be alone. So if it's just nitrogen, they're going to pair up, have a buddy system. They're going to be holding hands with another nitrogen atom. But here, nitrogen is not alone. Here, nitrogen is hanging out with aluminum. So she feels comfortable. So she's with aluminum, that's fine. She doesn't have to be diatomic. It's just when you've got nitrogen all by itself that it's diatomic. And that's true for all of those diatomic elements. It's a good point. Okay, so let's talk about the shortcut. So one thing you can do is, it's called crisscross. So books give different instructions for that. This is my instructions. So look at the charges. If they are different, then you can do crisscross. Down here with Al3 plus and N3 minus. The number is the same. You don't want to do crisscross there. So here we can do crisscross. And what that means is we take the charge, the number of the charge on one ion. So this would be an understood 1, and this is a 2. So the understood 1 becomes the subscript on the other ion, and the 2 becomes the subscript on the potassium. And so we get K2S. It's like a shortcut, kind of a hack method. It works most of the time, but not all the time.
So the rule for that would just be as long as they're not super.
As long as they're not the same, crisscross will work most of the time. You should, though, look at it when you're done and say, is that the lowest ratio? Because what can happen is if you get something like SN4 plus and O2 minus, well, those charges aren't the same. Let's crisscross. What do we get if we crisscross? SN2O4. Is that the lowest ratio? No, it isn't. So to get the correct formula, you would need to simplify that. It should be SNO2. So there's an example of when crisscross doesn't exactly work. Works most of the time, though, and that's why students like it. It's easy. It's better, though, if you understand what's going on here. We're looking at these individual particles, and they've got charges, and we're trying to find the smallest group that when we get them together, it all adds up to 0. Any questions? So naming ionic compounds. Some compounds have common names, but all compounds also have a systematic name. And so, sodium chloride is its systematic name. Its common name is salt or table salt, right? We're going to learn how to write the systematic names for different compounds. You have to identify the type of compound. There are different sets of naming rules. Just like in different cultures and in different countries, we have different ways of naming our children, right? So with these, so if you want to understand someone's system of naming, you need to know what culture they're from. So here are examples of ionic compounds. And if you look at these, the first element is a metal, nonmetal. Metal, combination of nonmetals. Metal, combination of nonmetals. Metal, combination of nonmetals. The first one's a metal. The only exception is if it starts with NH4. So we have to identify this as an ionic compound. And then books always like to organize these ionic compounds into two types. I think it's a little silly, but everybody talks about it this way, so we're going to do it anyway. The first type is metals whose charge is always the same, and that's the ones we've talked about so far, group 1A, 2A, and 3A. They always have the same charge, and we can predict what it is from the periodic table. The second type of ionic compound has a metal with a charge that can be different depending on what compound it's in, and these are mostly the transition metals. So these are the elements, the metals that form only one type of ion. They're the group 1A, the group 2A, group 3A, aluminum, and then zinc and silver. Scandium is also in here, but that is so unusual that we're just going to kind of overlook that one. So this is groups 1A, 2A, 3A, zinc, and silver. Groups 1A, 2A, 3A, zinc, and silver. Zinc is always 2 plus, silver is always plus. So groups 1A, 2A, and 3A, those are easy. The charge is the same as the group number. How do you remember zinc and silver? Here's aluminum, it's +3. This looks like going downstairs, right? Going down the stairs, +3, +2, +1. +3, +2, +1. And I'll be saying this little phrase over and over and over again. Groups 1A, 2A, 3A, zinc, and silver. These are the metals that form predictably charged ions. The name of the ion is just the element name. Do you have a question? Boron is not a metal. Yeah. We're talking about metals, and that's why hydrogen isn't in here. Hydrogen does form a +1 ion, but it's kind of special, and we'll talk about that later. And, what about gallium and indium, and I forget the name of that one. I think it's thallium, but I'm not sure. Well, gallium and indium do have +3 charges. We just don't run into them very often. So it's just easiest to say group 1A, 2A, 3A, and then zinc and silver. And some books will also include cadmium in here. Some books include nickel. Where's nickel? Why can't I see nickel? There it is, nickel. But we're going to go with what our book says. Okay, any question? So those guys form one charge. The name of the ion is just the element name. And then we have these other guys. These are all of the metals that are not in groups 1A, 2A, 3A, zinc, and silver. These can form more than one kind of ion depending on the compound. So for example, chromium. Sometimes chromium is +2, sometimes it's +3. How do you know? Well, it just depends. So the name for chromium with a +2 charge is chromium 2. And the name for chromium with a +3 charge is chromium 3. So we use a Roman numeral in parentheses after the element name, and that gives us the charge on that ion. We need the Roman numeral because otherwise in the name there's no way to tell what the charge is. This is an older system of naming where they would call it chromous and chromic, and that is still used, but we're not going to learn it. So if those sorts of names come up in a homework assignment, go look it up and finish the assignment, but I won't do that to you on an exam. I can't keep them straight myself. I just, I don't know. There's a reason we got rid of that. The one that's weird here is mercury 1. So mercury 1 is actually a diatomic ion. It's 2 mercury atoms overall with a +2 charge. So we call it mercury 1 because it seems like each mercury has a +1 charge, but it's kind of weird. So I've told you about it. If you forget, you can still do well in the class. So these names need Roman numerals. Any questions? We don't want to write Roman numerals for the others because that's writing extra stuff. And we're just trying to write as little as possible. Okay, so this is kind of the summary. Call it Mrs. K's tricks. So metals in groups 1A and 2A form ions with a charge equal to the group number. And the ones in group 3A that we will be asked about. Metals in this triangle are also predictable. These are going to be +3, +2, and +1. Basically, this is the bottom line. Groups 1A, 2A, 3A, zinc, and silver do not use a Roman numeral. Anybody else does. Okay? Then we have the monoatomic anions. Monoatomic means a single atom. So these are anions with a single atom. They've got a charge. The charge is predictable. We've looked at that on the periodic table. And these ions, their name comes from their element name. But we just change the ending of it. So fluorine is the element. Fluoride is the ion. Chlorine would be an atom of chlorine. Chloride is a chlorine ion. Okay? I think of the nonmetals as being feminine, and so you could kind of say that when you form an ionic compound, these guys are getting married, right? And so traditionally, the woman changes her last name. So here, the nonmetal is changing the ending of its name. I'm just trying to draw parallels with real life to help you remember stuff. And because it's fun for me. So you could do group number -1 to predict these charges, or count backward from the noble gases, -1, -2, -3. Okay? So when we name these compounds, a binary ionic compounds mean it's just got 2 elements. So we've got the metal cation and we have a monatomic anion. We're going to put the name of the cation first and then the name of the anion, which is just going to be its element name with the ending changed to "ide." So most compounds have 2 names, a first name and a last name. The formula is the metal first and then the nonmetal. The name is the name of the metal ion, followed by the name of the nonmetal ion. So KCl, to write the name of that, we name the cation. So this is K+, it's potassium. It is in group 1A, so it doesn't need a Roman numeral. So it's just potassium. And Cl is the anion. So chlorine changes the ending of her name to "ide", and we get potassium chloride. These names are not proper nouns. They're not capitalized. And there is a space between the 2 names, just like you leave a space between your first name and your last name. So for CaO, the first element is calcium. That's in group 2A. Doesn't need a Roman numeral. So we've got calcium. And then we look at the second element. That's the anion, oxygen. Monatomic anion, change the ending to "ide", oxide, calcium oxide. Any questions? You should have gone over this in your previous chemistry class. It may not have made a lot of sense, you may have forgotten it, but that's why I'm not spending a ton of time on this. Okay, so here's this compound, Ag3N. Let's name it. Well, we need to look at the individual ions. So there's always 2, right? So there's the silver part and there's the nitrogen part. So Ag, is that in groups 1A, 2A, 3A, zinc, or silver? Yeah, it's silver, right? So it does not need a Roman numeral. So I'm going to write its name, silver. The other ion is nitrogen. Nitrogen changes the ending of its name to "ide", And so we get silver nitride. Any questions? And we should also be able to write the formulas from the names. So here's the name of a compound, rubidium sulfide. Well, we got to find rubidium. It's Rb. What group is it in? Group 1? So what's the charge? 1. It's a metal, so it's positive. Sulfide would be S. The I tells us this is an anion. What's the charge on the sulfur ion? Count backwards. -2, right? So we've got rubidium with a +1 charge and sulfide with a 2- charge. How do we put these together so that overall it's neutral? Well, you could do the crisscross thing, or you could think about it. Let's total up our positive and negative charges. Here I've got -2 and I've got +1. That doesn't add up to 0. So I need more positive charges, right? So I'm going to put in another rubidium ion, and now I've got +2 and -2. So the formula will be Rb2S. If you have sloppy handwriting, when you get to the formula, slow it way down and do it carefully. Okay, I need to be able to read it. Any questions? What about that other type of ionic compound where the Roman numeral is needed? The idea here of naming them is the same. It's just that some metals need a Roman numeral and some don't. And it's a little bit like people, where there's King Henry and there was King Henry II and King Henry III and the IV. Because there's different variations. There's different members of that same family with the same name. And so we use Roman numerals after the guy's name to specify which one it is. But if you're like my son Michael Kawagoa, there isn't another Michael Kawagoa in the world, right? So does he need a Roman numeral after his name? No. Could you put one there? You could, but why? If we don't need it, we're not going to write that extra stuff. So with the metals, if we don't need the Roman numeral, we're not going to write it. It's groups 1A, 2A, 3A, zinc and silver, no Roman numeral. Every other metal ion should have a Roman numeral. So we write the element name followed by its charge in parentheses, written in Roman numerals, and then we have the nonmetal ion name. Okay, so just a quick refresher on Roman numerals. Keep doing the wrong thing here. Okay. So 1 is a capital I, and 2 is 2 capital I's, and 3 is 3 capital I's. Kind of boring so far. 4, well, let's skip him for a minute. 5 is a capital V. Don't ask me why. Talk to the ancient Romans. 4 is 1 before 5, and so it's an I before V. It's 1 before. And 6 is 1 after 5, and so it's a 5 with a 1 after it. And 7 would have 2. Now, on mastering chemistry, it is very important that you put these Roman numerals in as a capital I on the keyboard. If you type lowercase l, it's going to look the same on the screen, but mastering chemistry knows the difference. Okay? That was a fun one to figure out. Yes? So you're going to use the Roman numerals if the metal is not in groups 1A, 2A, 3A, zinc, and silver. If it's not one of those, then you use a Roman numeral. Zinc and silver. 1A, 2A, 3A, zinc, and silver. Should make up a song or something. I'll just say it over and over and over again. So let's name this guy. So this is a compound. We have Cr, which is chromium, and Br, which is bromine. So it sometimes helps to actually just divide this so that you know, okay, there's two things. I need to name the guy first and then the girl, the cation first and then the anion. So Cr is the element chromium. You know that because you memorize it. Then you have to ask yourself, is chromium in groups 1A, 2A, 3A zinc or silver? No, it isn't. That means it needs a Roman numeral. I don't know what it is yet, but I'm going to put parentheses here and leave space for the number, and then I'm going to go on and I'm going to name the anion, and I'll come back to the Roman numeral. So what would bromine change her name to? Bromide. They all change the ending of their name to the same thing. So chromium, blank, bromide. So how do we know what the charge on this chromium ion is? We have to figure it out. The periodic table's not going to help us this time. We're going to figure it out based on the charge of the anion. So what's the charge on a bromide ion? It's -1. Start at the noble gas is 0, count back is -1. Well, let's draw this just as the individual pieces. So I've got a chromium atom. I know there's only one chromium ion because it just says Cr, there's no number. Br3, that tells me I've got 3 bromide ions. Okay, so this is a representation of that formula. You okay with that? So what's the total negative charge on all 3 of these ions? -1 plus -1 plus -1 is -3, right? The total of the positive charges has to be the same magnitude as the total of the negative charges. These need to add to 0. This has to be +3, so that I have +3 and -3, that adds up to 0. I have a neutral compound. Everybody with me? So I need a total of +3 charge. How many positive ions do I have? I only have 1. I know there's 1 because the formula tells me there's only 1. It's Cr. It's not Cr2, it's just Cr. So I have 1 chromium ion, and I need a total of +3 charge, so that chromium ion has to have all of the charge. The charge is 3, so the Roman numeral is 3. So this is chromium 3 bromide. Any questions? So you do not need to memorize which charges a given metal has. I happen to remember that iron makes a +2 and a +3 ion. You don't need to know that because you will either be given the name where the charge will be told to you, or you'll be given a formula where you figure out what the charge is based on the charge of the anion. This is something that requires practice. Okay? On Mastering Chemistry, I put up some assignments there for extra credit, and I believe those are sort of adaptive assignments where if you do them correctly, you'll go through them very quickly. If you get some wrong, it's going to give you more because you need more practice. So I would highly encourage you to do those. Not necessarily before the exam on Wednesday, but you should do those. Okay, let's name this compound. FeS. So 2 elements. We've got 2 ions. What's the name of the element whose symbol is Fe? Iron. Iron. Is iron in groups 1A, 2A, 3A, zinc, or silver? Nope. What does that mean? Needs a Roman numeral. Okay. Because in his family, there's more than one named iron. And so we need the Roman numeral to tell us, are we talking about the dad or the son, the grandpa? Who is this? How do we name the ion that sulfur forms? Sulfide. So there we have most of the name. We're just missing the Roman numeral. We have to look at the individual ions and their charges to figure this out. FeS, we have two. One iron and one S because there's no subscripts. What's the charge on a sulfide ion? -2 from its position on the periodic table. So we've got a total of -2. We need a total of +2 charge. There's only one of these. So it's going to have both positive charges. So it's got to be +2 and -2. So if it's a +2 charge, then it's iron 2, sulfide. Questions? Let's write the formula for ruthenium-4 oxide. Well, ruthenium-4, what's the formula for that ion? It's Ru. Where did it go? 44. Yeah. There's ruthenium and there's rhodium. I don't know that ruthenium was on the list you need to memorize, so that wouldn't show up on an exam. So what do you do if it's not on an exam? You look at a periodic table that has names on it. So ruthenium, how do I indicate this 4? I'm writing the formula for the ion with its charge because that's what I have to do before I can write the formula for the compound. It's a 4+. So that's telling me the charge. It is not how many ruthenium ions I have. It's the charge on the ruthenium ion. And then oxide, that's from oxygen, and what's the charge on oxide ion? 2-. So I need to put these two ions together so their charges add up to 0. And I do that by figuring out the number of each of them. If you're a math person, we're looking for the least common multiple. If you're not a math person, let's draw pictures. This is one where crisscross could get you in trouble. So they're different, but I'm going to do it the thinking, understanding way. So here, if I have one of these, I have a total of -2 charge. Over here, if I have one of these, I have a total of +4 charge. Well, that doesn't add up to 0. I've got more positive charge than negative charge. So that means I'm going to add another of the negative ions. I can't change its charges. I can't take stuff away. I can only add more. So I'll add another one, and now I've got 2 of these, and together their charge is -4. So now +4 minus 4 adds up to 0. So I need 1 ruthenium and 2 oxygens. So the formula is RuO2. This would be a fun compound, but I don't think it exists. Are you okay? Silly. RuO2. Any questions? Just going to finish this section. So naming ionic compounds that have polyatomic ions. The polyatomic ions have special names, and you just have to memorize their names and formulas. There are some little tricks that you can find in there. I've not found them all that useful. You just have to memorize them. So here, NaNO2. Again, there's 2 ions. It's not sodium ion and nitrogen ion and oxygen ion. It's the sodium ion, and everything else together is a polyatomic ion. So we've got sodium. It's in group 1A, so it doesn't need a Roman numeral, so that's just sodium. And then this has a special name. It's nitrite, because you memorized it. And so the name for the compound is sodium nitrite. These are some of the common polyatomic ions. As you're doing problems and working on this, you should have memorized these already, but you get a little rusty. When you're doing these problems, don't just immediately go look it up. Try to figure it out, try to remember what it is, and then check yourself. You will learn better that way. Okay? So those are their formulas. Most of these have a single name. The exceptions are things like hydrogen sulfite. So hydrogen sulfite is sulfite with an extra hydrogen ion. So the charge is reduced by 1, and it's got a hydrogen on it. Here's hydrogen sulfate. It's sulfate with a hydrogen ion. And there's hydrogen carbonate. We have hydrogen phosphate, and then we have dihydrogen phosphate. That's one of the few times where we have a prefix, a numerical prefix in an ionic compound that's got 2 hydrogen ions. So there's some patterns within this, but phosphate, you just got to memorize that. So these oxyanions are ones that have a nonmetal and oxygen. And there are a series of them, and there is a pattern of the naming within the series. So the one that has more oxygen atoms ends in 8, and the one with fewer ends in "ite." So if we look at NO3 minus and NO2 minus, my pointer gets stuck there. Isn't that awesome? The difference between those two ions, the charge is the same, the number of nitrogen atoms is the same, the only difference is the number of oxygen atoms. So NO3 has more, that's nitrate. NO2 has 1 less, it's nitrite. I think of that as the light version. Bud Light has 1/3 fewer calories than regular Budweiser, right? Nitrite has 1/3 fewer oxygens than regular nitrate. So here we have sulfate and sulfite. Some nonmetals form a series of 4 oxyanions. So here's chlorate, and here's chlorite with 1 less oxygen. And then there's ClO minus that is even 1 less. So we use the prefix hypo, which means below. Hypodermic needle goes below your dermis, your skin. So hypochlorite has 1 less oxygen than chlorite. And then what if we have 1 more oxygen than chlorate? That's perchlorate. Per has to do with more, like hyper, more energy. So perchlorate has an extra oxygen. We see this same pattern with bromine. Here's bromate. Bromite has 1 less. Hypobromite, even 1 less than that. And perbromate has 1 more than regular bromate. Bromine and chlorine are sisters on the periodic table. They are in the same group. They behave similarly. Their ions have the same number of oxygens and the same charge. And so we could say, well, what about iodine? What would periodate be? Periodate, following this pattern. It would be just like perbromate or perchlorate, except instead of chlorine or bromine, it'd be iodine. So it'd be iO4 and a -1 charge. It is very warm in here. It's up to almost 80. So here's my trick. Memorize the 8s. I put a lot of the ites on that list, but actually if you just memorize this one, the 8, then you can get the per 8 and the ite and the hypo-ite from it. Just by the 1 more, the light version, and below that. Just so you don't get confused, I write this upside down of how it's shown in the textbook, because this is more, I think it should be on top, and the hypochlorite is below, it should be on the bottom. So when we name a compound like this, SnClO32, so we have parentheses around this ion because this ion has more than 1 atom in it, and the parentheses are like shrink wrap around it. It's one of those bundle packs at Costco. You can't just buy the chlorine atom. It's going to come with 3 oxygens also. So it's all shrink wrapped, and we've got 2 of those packages. But as with the other ionic compounds, there are just 2 ions. Sn is the metal, that's one of them, and ClO3 is the other one. So what's the name of the element Sn? Tin. Then you ask yourself, is it in groups 1A, 2A, 3A, zinc, or silver? No. It's actually not even a transition element. It's over in group 4A. That doesn't matter. The rule still works. Groups 1A, 2A, 3A, zinc, or silver. If it's not in there, needs a Roman numeral. Don't know what it is yet. And then we have to name this, ClO3. Chlorate. It's chlorate because it is. That's what they decided to call it. And then we have to figure out the charge. There's one tin ion, and there are two chlorate. Oops, that's not chlorate. That's perchlorate. Two chlorate ions. They have a charge of -1 because you memorize it. So total of -2 over here. I need a total of +2 over there. That tells me, because there's only one tin, that it must be +2, and so the Roman numeral is 2. Any questions? Writing a formula. Cobalt 2-phosphate. Same pattern. Write the ions with their charges first. So cobalt 2. Cobalt is capital C, lowercase o. And 2, the Roman numeral 2 tells me that's the charge. It's not how many. Phosphate is PO4 3- because you memorize what it is. You could do the crisscross thing here, or you can think about it and understand. So here I've got -3, and here I have +2. Those don't add up to 0. I need more positive charges, right? So I could draw another cobalt 2 ion in here, and now I've got +4. Well, dang, I went too far that way. Can't be helped. So I'll put another phosphate in over here, PO4 3-, and now this is -6. It's just not looking very good, is it? Going round in circles. I can tell you a story about my grandma and bread and jam later. Well, what do? Well, let's add another one over here. Just keep going. 2+, and oh, finally, +6. 6 is the least common multiple of 2 and 3. So I need 2 cobalt ions, and I need 3 of them. I can't count. 3 cobalt ions, 1, 2, 3, and I need 2 phosphate ions. Phosphate is a polyatomic ion. If I have more than one, I need to put parentheses around it. I've got 2 of those. If I leave the parentheses off, that could very easily be mistaken for 1 phosphorus and 42 oxygens. It's not what we mean. Questions? No, we're not doing that. We're stopping.